This video is to showcase how to use MSP432 to drive a VGA display to display color pixels on the screen. From the code, I have identified port 2.7 and 2.6 as horizontal sync and vertical sync, and port 4.0 to 4.5 as all the red, green and blue color output pins. The output pins would then come to the breadboard. We have red, green, blue, 3 color signals that will eventually come to the VGA display adapter. Each color goes through the exact same resistor network, as can be seen here. We have 1000 ohm resistor, which is the upper high resistance network, and we also have 3 resistors in series to create a 460 ohm resistance at a lower resistance network. The reason to do this is to have 4 different intensities for each color output.
When both color output pins of a specific color is low, then it outputs 0 volts. Then the screen will not display the specific color. If one of the pins is turned on, depending on which pin it is, it will either activate the 1000 ohm resistor, which outputs 0.23 volts, or it will activate the 460 ohm resistor network and output 0.46 volts. When both of the output pins are high, then we have the lowest resistance due to the parallel resistor network, providing a 350 ohm resistance. And the output voltage will be 0.7 volts, which is the highest acceptable in the VGA protocol. By mix matching all the color combinations, we can eventually produce 64 distinct colors using this board. Since MSP432 has a built-in 25 MHz oscillator, we can utilize that to create the horizontal sync and the vertical sync signals. Here, the sync signal are also input into the VGA pinout adapter. Now let's turn it on. Immediately we can see we have a white screen on the monitor and the LED 2 is shining white light. Since I already have the colors to produce pre-programmed into the flash memory, now by pressing the right button, it will change to the next color I program into memory, which is blue in this case. Since we have different shades of blue, now if I press the button again, it will change across all different shades of blue. Now by pressing the right button one more time, we'll go to the next memory location a byte later, and we'll have the green color. LED 2 also produce green color, as can be seen. Press the button one more time, we have the cyan color. By press the left hand button, the screen will split into 2 parts. The color on the right hand side of the screen will be the color of this memory location, and the color of the right hand side of the left part of the screen would be the color at the next memory location, 1 byte later. By pressing the right hand button one more time, we can see that the cyan color is now at the current memory location. Since the MSP432 is not capable to change its outputs on time, we are able to see some remainder of the right hand side color on the left hand side of the left color block. If we are able to store the picture in the ROM, then we can produce a more colorful picture in 64 colors, reducing memory access delay.